Today we will be learning how to find the surface area, and we'll be focusing on two solids, which is going to be the cube and the rectangular prism. Now, what do we mean by the surface area? So remember, in 3 dimensions, let me draw a rectangular prism here. In 3 dimensions, we have something like this, and the world that we see with our eye is usually in 3 dimensions. And let's say that you want to know how much of a material you need to make this kind of solid. Okay, let's assume that the inside is empty. We just want to know how much material this takes up on the outside. So an easy example would be if you're making a box, a cardboard box, how much cardboard do you need? And right now, as you can see already, as I'm coloring through these, the sides, they get overlapped because it's in 3 dimensions. So usually when you're finding the surface area, it's easier if you open this up. If you can open this up, I'm sure you've seen with boxes how you can open up a box. So let me number. So the rectangle at the bottom, the purple rectangle at the bottom is this rectangle right here. Okay, and there's one rectangle on this side and another rectangle on that side. So the red rectangle, I'm opening it up like this. Okay, and then the blue rectangle on this side and the blue rectangle on that side. They go like this. And then there's one last rectangle on top. There's a rectangle on top here. Okay, the green one. So let me draw it like this. Okay, so I've opened up the rectangle like this. If you fold this rectangle here, if you fold this up, then you will get this rectangular prism. And you are wondering what the area, the surface area. So this is what you need to have. This is the area that you need to calculate to make this box. This is how much cardboard you need to make this box. Okay, so think of surface area as like a perimeter. So in 2 dimensions, we had, I should be using equal sign here. In 2 dimensions, we had the perimeter to show the outside measurements. In 3 dimensions, we have the surface area to show the outside shapes, or the sum of the outside shapes that we need to know how much stuff we need to enclose a 3-dimensional shape. Okay, so this would be the surface area. And to find the surface area, basically you just need to add all the areas of these rectangles. Okay, so how would you find the area of the rectangles? Let me label in our original diagram here that this part is the length, this part is the width, and this part right here, it's the height. Okay, so we only need these 3 measurements to find the surface area. Looking back at this is called the net image, or the net image, the net image. Okay, so if you open up a three-dimensional object onto 2 dimensions, you get a net image, and this helps us to calculate the surface area. So let's look at the red rectangles, and if you notice, the 2 red rectangles are equal to each other. The rectangle on the front side here and the rectangle on the back side here are equal to each other. And what are the measurements for the red rectangle? Well, this length right here, this length is the width, right? That's that length here. And this part right here is the height. This part is the height. So that's going to be the same with our other red rectangle here. This is going to be the height, this is going to be the width, okay? And how about the blue rectangle on the front here and on the back there? The blue on the front is going to be, this is going to be the length, and this is going to be the height. Notice if you fold this up, this is also the height, right? So the 2 heights are going to meet when you fold it up. Same thing here, the 2 heights, this height will meet with that height. So that's a way of checking. When you fold this, are the same sides matching up with the same sides? Okay, so we have the L and the H for the blue triangle, so that's going to be the same for this triangle here. This is going to be the L, and this is going to be the H. And the purple and the green rectangle, they're actually the same rectangles. So let me use the same color here. So this purple right here and this green right here, they're actually the same rectangle. They're the bottom rectangle here, the bottom rectangle, and the top rectangle. Okay, they're the same rectangles. And the measurements for those are going to be L, this side is L. Again, this side should match up with the other side on the blue rectangle, so they should be the same. The L, and this side is going to be the W. This side's the W. And now you just have 3 different kinds of rectangles, and each of them have their own measurements, so you can measure their areas. Let me use a different shading for these rectangles here so that it's easier to see how they match up. So the red ones, I'll color in with red. Red ones here. The blue ones are here and here. And the purple ones are here and here. So the red area is going to be W times H, right? W times H. That's how you find the area of the rectangle. But there are 2 of those. There's a rectangle here, there's a rectangle here. So you have to do W times H times 2. And for the blue ones, you're adding the blue ones, L times H, right? L times H. But there are, again, 2 blue rectangles. So you do that times 2. And then plus the purple rectangles, we have W times L. But again, we have 1, 2 of these rectangles, so you do that times 2. So this would give you the surface area of a rectangular prism. Okay, so let me write the formula up here. Don't force yourself to memorize this formula. I would much rather have you to memorize the concept or know the concept. And if you see a formula like this, you can recognize right away that it's the formula for the surface area of a rectangular prism. I'm just going to use RP for the rectangular prism. But I'll write the formula up here. So 2 times W times H plus 2 times L times H plus 2 times L times W. Okay, so that's the formula for the surface area of a rectangular prism. Again, don't force yourself to write to memorize the formula, but you must be able to derive the formula once you know the measurements of a rectangular prism. So now let's try the cube. The cube is actually much easier than the rectangular prism, and you'll see why in a bit. It's going to have a similar net image. So a cube looks like this. Oops. cube looks like this. Okay, and the net image for the cube is going to look similar to a rectangular prism, except a cube has squares on all sides. So that means all the sides or the two-dimensional boundaries of a cube are the same. So each of these are a square. So each of these are a square, and each of them are equal to the other. So that simplifies a lot. That simplifies our calculation. So let's say that we have the measurement of that as S. That means we also know that this side is going to be S, and this side also is going to be S. And I'll color in the sides of the square or of the cube to kind of help you visualize which side matches with which side. But it doesn't really matter because all the sides are the same. So the red sides are those, the blue sides are over here. This one and this one. And the green sides are on the bottom and on the top, which are these ones here on this net image. Okay, and you just need to, surface area means you just add up all the areas of this square. And these are all S by S. So S times S. So the area of this square here is going to be S squared, S times S. And that is going to be true for the other red square and also true for all the other squares here. They're all equal to each other. So that's S squared, and there are 6 of those squares. Okay, so that leads us to the formula 6 times S squared. Okay, that's much simpler than the other formula we had for the surface area of a rectangular prism. So the surface area of a cube is going to have the formula 6 times S squared. Okay, again, since this is such a simple formula, I guess you can memorize this, but I would much rather have you to understand the concept of how this formula got derived and how to find the surface area.